Good afternoon. Our project is simulation of an autonomous radiation detection robot using SLAM and A-star algorithm. Our team members, myself Vishwaraja, Aditya V, and Sairam. These are some of the keywords. The abstract of the project is we intend to simulate an autonomous robot that detects radiation using two of the most prominent robot simulators. One is Gazebo and the other one is Webots. This is We are going to run the robot basically on SLAM and A star, which the robot will use for navigation and localization when operating in a completely unknown environment. So, as we know, A star is based on A star is based on a heuristic function that calculates the Manhattan distance between the current position and the target position. So F is equal to G plus H is the formula. Sorry, F is equal to G plus H is the formula. Slam is basically majorly used in when we don't know the environment is completely unfamiliar, and the robot needs to map the environment. And once the map is generated using the Slam algorithm, the A star algorithm uses it to and uses it to navigate the environment. G mapping is the SLAM algorithm that we're using in this case. It is basically based on a particle filter algorithm such as such as fast slam algorithm. Next, my friend Sairam will be simulating uh, the robot using slam and star in Gazebo.
Myself, Sairam. Uh, here I'm using Ubuntu 20.0.4, and the ROS version I'm using is Noetic, and the Gazebo version I'm using is 11.11. And yeah, the basically Ubuntu version. Okay. So I'm using Gazebo to model the world which the agent, the rover, will operate. So to open any launch file in ROS, the terminal has to be sourced with the respective version of ROS and the packages which we used for the simulation. So in this case, we are using TurtleBot and fake radiation node sensor. So both are being sourced using this command, and we are selecting the model of TurtleBot using this command, and the model is waffle file, and the modeled world file is going to be launched using the ROS launch command. Here is the Gazebo world file, and here is the TurtleBot rover. Yeah. So to control the TurtleBot, we are using the teleop operation, which comes with the package of the TurtleBot 3. And for launching this as well, we have to source the terminal. So, the controls for this rover is described here: moving forward, moving backward, stop, left and right. So if I press W, you can see the turtle bot moving front. Yeah. So from here, I'm going to simulate SLAM algorithm. So basically, installing a SLAM node, G mapping node from the turtlebot 3 repository and modifying it for the purpose we are using it. So I launch this. We can see RVIS window popping up. So the green points are sensing points from the LiDAR, which is attached to the turtle bot. So it's like 270-degree sensing range. So now when I move on the rover now after running the SLAM node, we can see the map being generated. So this way we actually create the map before we work with path planning, because for the path planning we have to know the details of the world beforehand. So we are using G to get the details, and this map will be saved using a map server after going through every nook and corner of the world, and this map, and it will be used for the navigation node. Here we are using a hybrid version of A star and AMCL. AMCL is adaptive Monte Carlo localization. So yeah, the A-star algorithm path plans for every 5 meter or centimeter units of distance. After that, it updates the path planning, and for that adaptations, minor adaptations, the AMCL will take over and adapt for the optimal path. Since the uh, map generated by SLAM won't be perfect, as you can see here, the map is distorted somewhat comparing to the world. So we are using the hybrid version that will mostly optimize the path. So, yeah, just a minute. The navigation is also done using arrows. First, we have to initialize the initial position of the rover in the world. We can use the grids of the world here. So we have initialized the initial position, and for the final position, we have to use this one. So we can also control the. Yeah, we can see the path updates every now and then using ANCL. You can also see the map is being distorted somewhat. This is due to the uh, like not a perfect synchronization between the wheels and the floor. So the odometer reference will shift towards the drifting, and hence the map distortion occurs. Yeah, the robot reaches the destination and also turns to the desired direction. So yeah, it's the simulation done in Gazebo. From yeah, Aditya will continue from Webots.
Hello everyone, this is Aditya V, and I'm here to explain about the VBOT simulation for this radiation detection. This yellow colored dot over here is the radiation that we created. Since VBOS is an open source software, we are allowed to create our custom made plugins and environments here. So this will serve as our environment, and this yellow dot is our radiation, and this is our epoch rover, and we have used this map is already being mapped using slam before. So this epoch knows what's and where are the obstacles. So these are the code for reaching this radiation contamination. So when I run it, this epoch rover has two sensors, two radiation detecting sensors. So using those two sensors, it will gather the information from this radiation contamination, and then it will navigate itself towards the contamination using the wavefront algorithm. Why using wavefront algorithm? Because it's much more simpler to apply in case when compared to A star. So that helps us and gives us more time to compute, and it's much memory efficient than A star. So that's an advantage here for wavefront. So at each step, it will just check for the radiation, the direction of the radiation where it is coming, and it will reach the destination perfectly without any problem. As I said, this total map is already being mapped using SLAM algorithm, and it's pretty hard to show you all the scores. So these are the values that we got. Okay. So these are the values that we got from our sensors. So this is the right value sensor, and this is the left sensor values. This is how the simulation work. You can see that the rover exactly went to the same position where the radiation is being there. Thank you.